Okay. Und ja, wie gesagt, wir bleiben beim Thema KI und wir machen weiter mit Prasad Akella von der Firma Drishti. Ich hoffe, ich habe das richtig ausgesprochen. Okay, er wird verkabelt. Dann kann ich die Gelegenheit nutzen, vielleicht nochmal zum einen nochmal auf die Podiumsdiskussion heute um 13 Uhr hinzuweisen, wo wir uns auch nochmal mit dem Thema KI beschäftigen werden, inwieweit KI die Zusammenarbeit zwischen Roboter und Mensch verändern wird. Es wird um Fragen gehen, ja, wo sind vielleicht auch noch so die Hürden für den Einsatz von KI in der Robotik, wo sind die Potenziale, wo sind die Use Cases. Da haben wir noch eine Podiumsdiskussion dann mit Werner Kraus vom Fraunhofer IPA, mit Dominik Bösel von Micropsy und mit David Reger von Neura Robotics. Das heute um 13 Uhr und insgesamt auch noch am Nachmittag volles Programm. Und morgen wird dann das Thema MRK, also Mensch-Roboter-Kollaboration, im Mittelpunkt stehen. Am Donnerstag Digitalisierung und am Freitag haben wir dann das Thema Nachhaltigkeit. Aber jetzt können wir, glaube ich, weitermachen im Programm mit dem Herrn Akella. Und sein Thema ist AI for Assembly, helping humans solve real manufacturing problems. You ready?
Yes, I am ready.
Great. So, the stage is yours.
Thank you so much. Good morning, everybody. I guess I'm catching you just before lunch, so I'll try and energize you so you can go get a good lunch there. I'm going to be talking today about something quite different than what you see on the shop floor here, on the show floor here. If you think back in time, every plant manager wants to drive safety, quality, and productivity. And between them and that goal are the human beings on the plant floor. All of us do things differently. In the morning with coffee, we're better than in the middle of the day. And so the path for 50 years now has been to replace people with robots. That's the entire goal of everything you see on the floor here. But I believe there's a second path here that's very important, and that's the case I'm going to make, that we have to actually empower all of the people we have, and you'll see some of the numbers, they're stunning, using the same technologies that you see on the floor to make them better. So I want you to keep at the back of your mind the spell checker, the humble spell checker. You write an email message, you make a spelling mistake or make a grammatical error, it fixes it, shows it to you, and you decide whether you want to make the mistake or not. And ideally, you fix it, and so you look like a fantastic writer. It's the same thing. What I'm going to talk today is about making every person on the line a fantastic operator without killing themselves. That's the central goal, and that's what AI is here for. And what you're seeing here is the first generation of capability that's never existed since Henry Ford. So that's my goal today, is to talk about how we take humans and machines, let them work together to deliver the operational excellence that we're looking for, or what the title says, AI for assembly, helping humans solve real-world manufacturing problems. So that's my goal. I'm going to take you on that journey for the next few minutes here. So if you look at all the robots on the planet that we've created for the last 50 years, adds up to 2.7 million. But on the plant floor today, around the world, are almost 300 million people. And we are producing a sum total across all of the vendors here of 400,000 robots a year. So you do the math on all of this, it's 100 years before you actually replace all of us. So the question is, for the next 100 years, if you've got people on the line, what do we do, right? That's the core question we're solving here. So the best tool that we have is the Toyota production system. It's a very methodical system. It ensures that we start with the foundation. This is called the Toyota house behind me. You start with the foundation, you train your people, you have standard work, and then you eliminate common problems systematically so that your system is producing as efficiently as possible. This is the best that we have in the world today. Everybody's Any of you running a plant right here, if I ask you how many of you running lean, how many of you are running lean? See, your hands are going up. So this is the best. Now the question is, can we do better? And that's where we're going now. It turns out that video is a fantastic sensor. It is the next generation sensor. There's a reason why all of us have security cameras at home, because video is so informative. The information channel in video is so rich. And so when you apply this video to the world of manufacturing, what we're looking at is this possibility of turning essentially manual data solutions. So the industrial engineer in your plant most likely goes out with a stopwatch, looks at the person, measures it, and comes back and gives you an analysis. At best, they analyze 10 cycles. And the person being observed is going to behave differently. So you've got biased data, non-statistically significant data, wrong data coming back to the system. Now, instead, if you could put a camera on top on every station, you now have the opportunity to understand the work. You don't care about the person, you care about the process. And you have the ability to understand what's going on, and that's what Drishti has done. We've created, for the first time in the world, the ability to take video and analyze video. So Google figured out how to mine text. Apple and Siri figured out how to mine audio. What we've done at Drishti is figured out how to mine video. So from the video, we're able to extract spatio-temporal information. So I'm putting that cell phone together. I have to do 3 steps in my station, and I hand it to the next guy. Did I do the 3 steps? Did I do them in the right sequence? And did I take the right amount of time for each one? That's the kind of information we're able to extract for every unit going down the line. So now you're talking about 100% sampling, about creating data at scale, and tying all the data back to video, because we can interpret video in the most easily. And that video can be analyzed in China, it can be analyzed in Mexico, it can be analyzed in Germany, and it can be analyzed in the United States. There is absolutely no need for any translation, because all of us can interpret video extremely well. So what we do is we extract that video continuously, and we turn it into benefits that you saw being talked about in the Toyota house. We can show you how to reduce your defects, how to balance your line, how to train your personnel, and how do you narrow warranty recalls. I mean, we know any number of companies which have to sort of say, okay, every unit made from January 1 to June 30th, I'm going to recall. Instead, what happens if Prasad on the line was making the mistakes, and all the other workers were doing a perfectly good job? Why would you recall everything? Why not just recall the units Prasad made? We have that ability today thanks to what we have. So I'll show you what that looks like. So that is the central goal. Create a body of data using AI and use that body of data in different ways to impact your business in a more efficient way. So how does this work? We put a video camera on every station. And then from that video stream, like I said, we create the data, and we call this action recognition. So if you go to the Cognex booth or Keyence or anybody here, everything they show you is what's called object recognition. You look at a frame, and in that frame, you see, what am I seeing? What we're doing, as I said, is looking at the video and pulling from the video. And let me give you an example. So watch the human being on the left. On the right-hand side, watch what the AI is saying. And this is all happening in real time. It's a video, it's a recorded video, but all this happens in real time. So you can see this person taking the first step, and the system says he's installed the shroud. And you keep going down, so we can test for completeness. We can test for sequence, and we can test for time as that goes on. So you see that all actions completed, it took 32 seconds for it to happen. Now contrast that with this scenario. And it throws up a bunch of flags. This is the spell checker running in a manufacturing environment. So this is the base technology, what we call action recognition. And everything that we do evolves from this point on. I love questions. If you have a question along the way, just put your hand up and I'll answer your question as we go along. Or we'll pick up the questions at the back end, because I know that you're thinking about this and you're wondering what's going on here. So I'm happy to answer those questions. OK, so now you've got the data. What we do is we deliver the insights in context of manufacturing. And we work with you to drive those insights into actual production changes. So to do this, we do that in real time, so that you can actually tell the operator as he or she is doing the job that something doesn't look quite right. And the reason you want to do it as the person's doing the job is if they make that mistake and send it on, you have to worry about rework. And the cost of rework is 5 times the cost of getting it right in the first place. So any mistake, you want to catch it right there, deal with it before it gets moved down the road. The second is the solution is vertically integrated. What this means is like an MRI machine. You know, when you go get an MRI scan, the lab technician doesn't know what's going on inside. He or she knows which buttons to press to give you your scan. And the scan that comes out, the radiologist interprets, but he or she has no idea what is done inside the machine. So same thing here. All of what happens inside is hidden from the users. So our goal is for the quality engineer, the industrial engineer, and the line associate to be able to use the results and not worry about the technology itself. So that's what we mean by it's vertically integrated. And you'll see me layering AI over the Toyota production system, all of the processes you're used to. You're used to doing the Gemba, you're used to going and doing Jidoko, all of that kind of stuff that you do, we can show you right in a minute. So I'm going to take you through 5 examples that will bring all of this to life for you. So the first example here is, because we got video, your plant can be in Mexico and China. You can be here in Munich, or I can be in Palo Alto. We can all see what's happening on the plant floor without having to travel to the plant. That's what you're going to see first. And the second is a customer calls up and says, you shipped me a defective unit. Now the question is, was it defective when you shipped? Or did the guy drop it and wants to claim money and is therefore saying, you shipped me a defective unit? So you're going to see here that we can type in a serial number, and you type the serial number in, you'll get a video birth certificate of that unit being built. So specificity to that one unit level. So let's watch. So wherever you are, we can bring back the entire plant to you. I'm just showing you 3 stations in a line, but we've got customers with 100 lines, 100 stations, and we can bring back all of that video for them in real time. Now this is the search engine looking at that serial number. So I'm typing in a serial number, whatever the serial number was. And like YouTube, in 1 second, you actually have the entire birth certificate of that unit that you built. So imagine Samsung, phones blowing up in your pockets. What do you do next? Do you go and do an Ishikawa diagram, get 50 people into the plant, and you figure it out? Or do you type in that number and go to station 3, where that issue might have, the battery may have been inserted, and figure out did the guy insert the battery right or wrong? So essentially, you're taking this uncertain process and turning into a deterministic process, and you're taking weeks, man-weeks of effort, and making it 2 seconds of work. That's the kind of efficiency we can drive, because we're able to actually take the video and create metadata out of the video. Second example. So I'm going to show you how we can reduce defects in your assembly process. And I'm going to actually, if you remember that our action recognition, it's throwing up a flag saying there's an error, there's a warning, or there's a good cycle. So you're going to watch here, on this day, September 1 last year, they made 1 mistake. So you're going to dig into that mistake here. And you're going to see that when you click in, so okay, they made 145 errors and 48 good cycles. So you click in on that one bad cycle when they made the error, you'll see the stepping through standardized work. Every step the guy was supposed to do, you can actually see him doing it or not doing it. And once you do that, you have a sense of what happened. If you click on the red box, you'll see in step 4, he didn't follow the right sequence. And if you don't follow the right sequence, you may deliver a defective part. And so what happens now is now you're able to go back and either go fix it before it gets shipped out, or ideally you fix it on the spot so that you have your defect rates drop. We've seen customers report a reduction in 50% in defect rates, right? And so that's the kind of impact you can have here. And these guys are running single part per million defect rates, because that's what you need to do when you have a car That's what the OEMs require of you. So what does this mean? It changes how you train your people. Because you know where the common mistakes are, and you actually show them video. It's like me learning how to play golf. And if I think I'm hitting the ball correctly, when I watch a video replay, I'm like, oh, I'm looking there instead of looking down when I hit the ball. And it turns out humans can process that very well. Or if you watch football, American football or soccer, the coaches play the videos again. Why are we playing videos? Because we all learn from videos very efficiently. So that's an example of either using it before or using training on the job. Another example is you may have sent a design change through. The engineers in headquarters have made a design change. It's going through. And suddenly, your people are struggling to put that part together. Today, there's a pissing match between the two. One says, oh, it's hard. The other says, oh, you're stupid. Now, instead of all of that, if you can actually just simply send the video back and say, guys, here's the video, 10 videos. Here's the statistics on this. There's no argument about the fact. Now the argument is how do I fix it, which is exactly what you want to be doing. So that changes the business process in your company in making all of this happen. So collaboration is a completely different level because you've got video and data to anchor all of that. So third example, how do you balance your lines? How do you increase throughput? And remember, manual lines are 80% of production around the world. So the chances are you're blind to what happens in 80% of your plant today. So wouldn't you like to know what's going on there? That's what this is all about. So you're seeing on the top, across the shift, 8 hours of the shift, units being built. And down below, you're seeing cycle time. OK? Now, as this plays, what you're seeing here, I'm hoping the video is playing. OK, the video is playing. So what you're able to see here is 2 hours into your shift, we can start projecting for you how many units you're going to make today. Because it may turn out that 10% of your crew did not come in. You got a crew that's not very experienced, and they're not producing at a high rate as you expect them to. You now have to decide, do you want to run overtime or not? There's a whole process. You want to get approvals for that. Then you've got to tell the team so they can call home and say, I'm going to come home for dinner 1 hour later today. All of those processes become possible. Now, you're also looking down below at the cycle time, and you're saying, why did it take longer? You can actually see the video. Every data point is tied back to video here. And now you're looking here at the line balance. You can see there's a 10% opportunity to improve. It's because operators 2 and 4 aren't as loaded as operator 1. So you can really now actually balance your lines using the data coming here, build your Yamazumi more effectively. And finally, variance is what kills the ability to deliver cycle time. So you can actually see statistical plots of cycle time with the outliers, because the outliers are what kill you. You can come and look at any outlier, and bang, you got video tied back to that outlier. So you really are changing the job of your industrial engineer. Instead of actually gathering data, which is the most boring thing to do, you're actually giving them data to solve problems, which is the exciting thing. That's why they went to school to become industrial engineers. And this is the value that you get out of the process. Next example. I'm the shift manager. I'm coming in the morning at 6 o'clock in the morning. What happened yesterday? What are the problems the guys had? What should I be prepared for? So what you're seeing here, OK, the laser doesn't work. On the top, you see the goal was to hit 71 seconds cycle time. You actually came in at 86 seconds. You didn't produce as much as you should have produced. Why? If you look in the middle there, station E110, turns out across all 3 shifts, E110 was your bottleneck. It took much longer than expected. In fact, there's a 79% overcycle. So now you know, OK, how to start solving my problem is to start with E110. And then you look at it across the board, you have cycles that are taking longer than your 71-second target. So you know it's just not E110, but even the other stations are laggards. And then you look further, you see your shift 3 in particular is bad. So whoever's running that shift had some problems, and I know I need to go back and see what happened on shift 3. It's that level of detail that really lets you run your plant that we're focused on. Last example here. OK, last example. you remember, as the person was doing the job, we were counting the errors and the warnings. If you plot those errors and warnings across the shifts and the rotations, you can now start plotting them. A little hard to see in this light, but you can see if errors and warnings, shift 1, rotation 1 is particularly bad. What that means is you can go train your people. You can show them, look here, we know that we had some issues. Let's go understand what the issues are collectively and start figuring out how we train our people. This is now, you don't put everybody through the test. I mean, I'll give you an example. If you're a goalie in the soccer team, I don't want to train you on how to kick the ball well. I only care about, are you blocking the goal well? It's the same thing. You're narrowing it down, and you're focusing the attention on the troublesome points for the people who are having challenges. It's not everybody having to go through the same training process. So it really helps you drive what's going on your floor. So now let's tie it back to where we started with the Toyota production system. As we said, there's the Toyota house. Now, what Drishti does for you is it helps you understand your standardized work. Where am I deviating from standardized work? And this data is being generated at scale, right? Second, with that understanding, I can figure out whom to train, what to do about it. With that understanding, I can actually sometimes coach in real time. Maybe it's required, maybe it's not. It depends on the importance of that station and how much quality you're trying to drive. Oftentimes, we watch our videos, and it turns out you want them to build single-piece flow, but they're building in batches. Now, you want to go back and make sure that you're actually following the right way of building it, and this becomes obvious. Otherwise, when you're on the line, they will build single-piece flow. The minute you leave the line, they'll do what they want. It's not bad or good. It's just that Toyota has shown us there's a certain way in which you build, so you don't stress your people out. How do we get them to that point is the answer there. And finally, you pull the and-on cord. You empower your people to pull the and-on cord. Turns out that sometimes they can't see the problem, whereas our system can spot an issue. So now, essentially, you give the operator the opportunity to pull the and-on cord, or you give the AI system the opportunity to pull the and-on cord. And now, between the two, they're catching all the main issues. So you've got completeness in detection, the human brain and the AI together trying to identify issues. So here's the kind of benefit that you get from it. Tens of percentage points of lift in productivity, in defects reduction, all those kinds of things coming from our systems. And we see this across a slew of customers. And the way I want you to think about this is the way I think about the problem, is that your line associate is the actor, the primary actor on the floor. The line associate and your robots, your automated equipment, and your humans. What we're doing here is we're giving you visibility into the human processes, and that touches all kinds of processes around business processes that drive your company. We've talked about HR, we've talked about process, we've talked about quality. Think about warranty. When that phone was blowing up, if Prasad is the only guy, you can narrow down the window, and you lose not $2 billion, you lose maybe 200 million. A huge difference in economic outcome because you got the data. So with that, I just want to share what Toyota thinks about it. The fact that this data is there at scale, that lifts Toyota's own system to the next level. Those guys are running continuous improvement all day long. And for them, they see Drishti as the next big step up in driving that improvement process. And to give you a sense of whom we work with, some of the largest automotive manufacturers, the auto tier ones, medical device companies, and increasingly we're working with electronics companies. So if you're interested in working with us, I'd love to talk to you after this session. And the thing I want to leave you with is we've got gobs and gobs of data. We understand this process incredibly well because we've seen so much video go through our systems so far. So with that, I'd like to close out with my final comment here, which is automation has to move forward. All of these companies have a future because you want to take the dirtiest, worst jobs off the back of the human and put it in the machine. But there are many, many jobs that cannot be automated with the technology we have. And in those cases, we've got to help the person. And we believe that you use the automation technology to create the information to help the people. And that's fundamentally what we're offering here. Happy to take questions and go from there.
Thank you very much. Thank you very much. Quite impressing how you